All right, here we have lesson 3, using the tangent ratio to calculate lengths. In lesson 2, we were looking at finding a missing angle in a right angle triangle using the tangent ratio. We can also find a missing side of a triangle. So example 1, determining tangent ratios. So we know that tan theta is equal to opposite over adjacent. And in this question, it's telling us that the value is 60 degrees. And if you put tan 60 into your calculator, you get 1.73, which we know as a fraction would be over 1. So our opposite value is 1.73 and our adjacent is 1. Now, if we look at our triangle, here could be our value of 60, which would give us the opposite is 1.73, and the adjacent directly beside would have a value of 1, this being the hypotenuse. Now, when we're going to determine the lengths, it's asking us to determine the length of A to B to the nearest tenth of a centimeter. So our first step is to label the triangle. So we're going to look at what do we have. So if this is our triangle, we're looking from 30 degrees. We have the adjacent side, and we're looking for the opposite. So we have tan 30, as we're given in the triangle, is equal to the opposite over the adjacent. And now I substitute the information I know. So I have tan 30 is equal to AB, that's the length of the side here, over my value of the adjacent, which is 10. Now I need to solve for AB to get it on its own. So I'm going to multiply by 10 on one side. Whatever you do to one side, you do to the other. So now I have my calculator, tan 30 multiplied by 10. The length of AB is equal to 5.8, and in this case, it's measured in centimeters. Looking at example 3, determining the length of a side adjacent to a given angle. So we look at our angle, we see that angle F is 20 degrees. So we have tan 20 is equal to opposite over adjacent. So I have tan 20 is equal to, what information do I know? I have the opposite value. I have 3.5. So 3.5 on top over, in this case, let's call this side X that we're solving for. Now, if the value that I'm solving for, X, is on the bottom, I simply can swap these values. X is 3.5 divided by tan 20. Now in your calculator, 3.5 divided by tan 20 gives you our value of X, which is 9.6 centimeters. Done. All right, now let's take a look at example 4, using tangent to solve a problem. What is the height of the building in the diagram? So I want to orient myself from this angle that's given, which is 25 degrees, and the value that I have is directly beside, so that is adjacent. So I have tan of 25 is equal to opposite over adjacent. I'm going to substitute the values that I know. I'm going to solve for, let's call this X. So I have X over 35 feet. I want to solve for X, so I want to isolate my variable. To get X by itself, I need to multiply by 35, so it cancels out. What I do to one side, I do to the other. So in my calculator, tan 25 multiplied by 35 gives me my value of X at 16.3 feet. Always remember to put your units. Example 5, we have a right angle triangle, and the side opposite of a 31-degree angle is 41 centimeters. So we have it labeled here for us. We have a 31-degree angle. The opposite side there is 41 centimeters. It wants us to solve the triangle. So find the values for all three sides and all three angles. Now we can use a 180-degree rule to solve for angle A. So angle A is equal to 180 degrees minus 90 degrees, which is our right angle, minus 31. This gives us the value of 59 degrees for angle A. We now have all three angles solved. We now have to solve for side A and side C. Now, if we solve for side A, using the tangent ratio, we can then use Pythagorean theorem to solve for the hypotenuse. So let's use tan 31 is equal to opposite over adjacent, and the value we were given is opposite. So tan 31 is equal to 41 over adjacent, or in this case, it's called A. We're going to swap our values here when the unknown is on the bottom. So A is equal to 41 divided by the tan of 31. So using our calculator, 41 divided by tan 31, the value of A is equal to 68.2 centimeters. I'm now going to use side A and side B using Pythagorean theorem to solve for side C. So I have A squared plus B squared is equal to C squared. The value of A is 68.2 squared plus 41 squared is equal to C squared. 4,651.24 plus 1,681 is equal to C squared. I have 6,332.24 as my value of C squared, so I take the square root of that. The length of C is 79.6 centimeters. We have now solved for all the missing angles and the missing sides. All right, so that's it for lesson 3. Take a look in the OneNote pages for some practice questions, and I'll see you later.